Welcome to the Optimizing Your Dedicated Fleet, How Much Can You Save webinar, presented by Seacliff Consulting. Today, we're demonstrating how to decrease your logistics spend through optimizing your dedicated fleet. Let me start by introducing everyone to Seacliff. We're a management consulting firm focused on solving strategic business problems within logistics, operations, and supply chain using analytics and big data technologies. Our solutions are focused on supporting decisions that drive profit optimization across the full product lifecycle. My name is Philip Felice, a management consultant here at Seacliff Consulting, and I will be one of the presenters here today. I have a background of 10 years of experience in product engineering, manufacturing, and design, and recently my focus has been on product variation and internal and external logistics optimization. I'm joined today by my co-presenter, Logan Lindsay. He's also a management consultant and has a background of 10 years experience in manufacturing and supply chain with a functional focus in linear optimization, constraint modeling, data analysis, and visualization. So now I'll hand it over to Logan to go over the agenda. But before I do, I'd like to point out that we will be answering questions at the end of the presentation. So if at any point you have a question, go ahead and put that into the questions chat. We'll be able to see it there at the end. Thank you.
Thank you, Phil, for that introduction. Today, what we're going to do is we're going to start out by reviewing the current state of today's supply chain. And we're going to follow that up with a review of what a typical logistics planner's process is going to look like. And from there, we're really going to examine that same logistics planner's process, but through this lens of an optimization model and how that can lead to big savings for your company. Then what I'm going to do is I'm going to hand the floor back to Phil, who will explain how to transform today's logistics scenario into an optimization problem and ultimately into that optimized solution. We don't really expect anyone to walk away with the ability to build your own model. There's no test at the end, so no pressure. But what we do want is everyone to leave with this ability to start a conversation within their organization. And then lastly, we'll address our opening question, which is how much can your organization save? We're about 2 years since the start of the pandemic, and the world is still deep in this supply chain crisis. We've got a lot of experts who are saying that we're far from out of the woods. I know everyone on the call today has most likely been affected by this, whether you're hearing about it on the news every day, or you're like me and you're still waiting for some furniture to arrive. Many of you have been seeing the impacts of the supply chain shortage directly hitting your bottom line as you pay exorbitant rates to deliver your goods to the customers. This isn't something that's just occurring in our ports or with shipping containers. This is happening across all modes of transportation. We're actually seeing large spikes in costs across US domestic trucking and rail. Both of those were up roughly 23% in 2021. And a lot of experts are expecting to see these rates continue to rise through 2022, with many projections saying best case scenario is we'll start to see prices start to level out the first quarter of 2023. And so for the remainder of 2022, we're pretty much expected to be a capacity constrained market with just a lot of inflationary pressure and equipment disruptions. And all of these driving factors have left us with record high transportation costs. I just threw a graph up on the top left here, and what this does is just kind of show you where we are in relation with the past few years and how this is leaving us in a position where we're forced to work harder and harder, and we're paying more and more to move our goods. This takes us to a company that I've worked with in the past that has found a solution that is allowing them to still capture savings, even during a time with this rising prices. And this process really grew from a need of many logistics planners feeling overwhelmed, spending all of their time trying to assign orders to carriers without this ability to strategically plan or work towards goals that would really help them move the company forward. And this was leading to a lot of added stress, a lot of burnout, and just constant increase of costs. So to put this problem in a little bit of context, for this organization, a 10% increase in freight cost would lead to an increase in their logistics spend of roughly $190 million. And so as you can imagine, at a time like this with a 23% increase in logistics costs without any relief in sight, really looking at close to a $500 million increase in logistics spend. And so between the raising rates and a burned out team, they had a problem that needed to be resolved really quickly. What we are focused on is a solution to this problem. Our goal is to enable companies to take control in areas they can and use that control to drive savings. Today, we're focused on over-the-road logistics, specifically around how to properly utilize that dedicated fleet or planned capacity. So the goal today is to really bring back order to your logistics process, and through that order, ultimately save you money. So before we jump right into today's scenario, what I want to do is I want to level set on just a few key assumptions and a few things that are going to help this scenario kind of go smoothly and help us all to get the most out of it. The main thing here is that we're focused on a dedicated fleet. And so a dedicated fleet is going to look a little bit different for everyone, but the key here is guaranteed capacity and negotiated rates. Even if you've got tractor trailers getting dropped in a drop yard and replenished every day, or it's just simply a contract that you have with carriers for guaranteed trucks at guaranteed rates, it's going to work for you. The key here is just guaranteed capacity with guaranteed rates. From there, the next piece is that we're really focused on full truckloads today. And so we're not going to be looking at LTL or less than truckload, and we're not going to be looking at anything within backhauling. So the key here is full truckload. Each shipment has simply one destination. The next piece is one shipping center. There's a lot of ways that we can grow the complexity in this problem, but to just keep the scenario simple for today, I want us focused on simply one shipping center, and with that one shipping center, 4 destinations. And we'll see as Phil kind of gets into the more technical side, even how this really scaled down version still offers a lot of complexity for logistics planners to solve with the amount of combinations that are possible. And then lastly is an item that really we're all painfully aware of right now, which is that limited capacity. We're all aware of the driver shortage and the limit on tractor trailers that are available right now. We really program our models to reflect reality as much as possible. And so in today's scenario, it's no different. We're going to be abiding by those same principles of limited capacity. And so the idea here, there's a replenishment period after a truck is utilized. Once a carrier reaches its capacity, it has no more capacity until it can be replenished. What I'd like to do is ask everybody to put themselves in the mind of a logistics planner. You come in the morning and you log into your computer and you see that you've got a whole list of orders that are going to need to be fulfilled for the day. And so your goal is to assign these orders, assign these lanes to carriers so that your products can get delivered to the customer. And so that first order, when you sit down, you're going to see Dallas, Texas to Tulsa, Oklahoma. So the first thing you're going to do is you're going to go to your rate sheet and you're going to say, okay, who's the best carrier for Dallas to Tulsa, Oklahoma? Okay, carrier B is my cheapest option at $1,100. So let me go ahead and assign that. And you can see your total spend for the day is now going to be reflected $1,100. And then you're going to go to the next order, Dallas, Texas to Detroit, Michigan. And you're going to kind of continue to iterate through here and follow that same process. So I'll go over to my rate sheet and I'll look Dallas to Detroit, Michigan, $1,500. The next cheapest option is carrier B. So if I go with carrier C, I'll be making a good decision. I'll save the company $100. So let's go ahead and lock that in. And we're going to kind of continue to go through this process. And this is what it looks like for a lot of planners out there is orders are coming in, they're looking at their orders, they're looking at their rate sheet, same thing, Dallas, Texas to Chicago, Illinois, carrier C, I'll save another $100 if I assign it to carrier C as opposed to carrier A. So let me go ahead and lock that in. And if I can ask you to kind of look towards the bottom left hand of the screen here, you're going to see that capacity chart. This is where we get into that concept of limited capacity. And so as we can see, carrier A's got 8 trucks available, carrier B has 5, and carrier C has 3. If I'm looking at my trucks used, I've assigned 1 to carrier B, and I've assigned 2 trucks to carrier C. What I'm seeing here is I've already used 2/3 of carrier C's capacity for the day, so I've only got the ability to assign 1 more order to carrier C. So I'm going to kind of continue to go through this process, and by the time I get to order number 7, Dallas to Chicago, I'm going to go back to my rate sheet. Dallas to Chicago, cheapest carrier is carrier C, but as you can see now, our capacity is completely full. I've got no more trucks available to assign a carrier or to assign a lane to this particular carrier. And so that means I have to go with my next option. This is where we're going to assign carrier A. And this is where we kind of start to see how there could be a potential problem with this approach. So carrier A, I've now spent $100 extra to go with this carrier because carrier C has no capacity. I'm going to continue to go through this, and by the time we reach our 10th order for the day, another Dallas to Chicago order, what we're going to notice is that all of carrier B's capacity is completely full and all of carrier C's capacity is completely full. So from an assigning order standpoint, yeah, this makes life pretty easy, but what we're going to notice is that carrier A is our most expensive option. As I start to assign carrier A to these orders, I'm going to see how quickly my total spend for the day starts to boom. By the time I get to that last order, Dallas, Texas to Boston, and I look at my rate sheet, I'm saying, wow, so carrier A is $500 more expensive than carrier C. So where I initially thought I was making the right decisions early on and saving $100, that $100 actually ended up costing me $500 on this particular order. It's really not a net savings at all. And there's not an option to not assign carrier A here. We can't miss deliveries. We can't tell our customers that, well, it's simply too expensive to get you your product. It's more important to get the orders to the customers. And so we go with that option and we assign it to carrier A. So what I want us to do now, I want us to take a second look at this problem, but we're going to look at it through this optimization lens that I mentioned earlier. The idea here is that instead of going through this iterative process where the logistics planner is manually going line by line, order by order, and assigning these carriers to these shipments, what we're going to do is we're going to look at everything from a holistic view, and we're going to try and say, okay, I don't want to prioritize the cheapest order for any individual lane. What I want to do is I want to prioritize the cheapest possible solution for an entire batch of orders. And so in this example, we're looking at 16 orders. All of these will get loaded into the model, and the model is going to know, okay, this is my demand, this is the carrier capacity I have, and it's going to solve for all of it at once, assigning each carrier to each lane and each order. And so what we're going to see here, our total cost is $700 cheaper because we're not looking at it individually order by order. Because when we go through that order by order process, what we're really at is just at the mercy of which orders we happen to look at first or which order comes across the planner's desk first. And so what we've done is we've kind of restructured the problem to say, let's look at it from a zoomed out view and making sure we're making the best possible decision to save money for the company as a whole. The iterative approach, we're saving ourselves $100 here and there on those first orders, and that really came back at the end when we didn't have any of carrier C, our cheaper option, where we had a bigger delta between carrier C and carrier A, maximize our savings. And you can see how at the top we sacrificed saving $100 here and there to save close to $1,000 at the end. We want this to be an automated process. The way this approach works is that this will be directly fed into or directly connected up to your transportation management software. And it's going to be able to pull out your capacity. It's going to be able to pull out your lanes and your orders. And we're going to automate this because what we want to do is we want to free up the planner's time and let them really focus on the items that only they can solve. There's going to be situations where there's hot orders that need a lot of their attention, or there's going to be orders that we don't have capacity for that are going to need to be addressed on the spot market. So we want them focused there. And we want our model to do this labor intensive number crunching portion so that they don't have to just assign orders and deal with our dedicated capacity. We'll let the model make the best possible decision and ultimately save us time and money. And so it's going to give us a lot better of a result. And then in this example here, we're just kind of looking at a batch size of 16. We can adjust or run this analysis in a way in which we'll know what is the ideal batch size for your demand or for your shipping center. In this example, for this client, it was 16, but for you, depending on what kind of agreements you have with your customer and how much capacity you have, it could be smaller or it could be far larger. What we do is we'll run an analysis to break up your orders into the ideal batch size that's going to allow you to kind of maximize your savings. I want to go ahead and hand this off to Phil, who will go into the more technical details around how you can take this business problem and break it down into something solvable. We really want to help equip everyone on the call today with the ability to have the needed discussions within their organization to begin investigating what a solution like this could mean for your bottom line.
Thanks, Logan. Here we'll go through the more technical explanation of both why and how we use our analytics process to provide insights for decision making. To illustrate the complexity of determining the optimal fleet distribution, I'd like to first go through the numbers. So in our example, we have 3 carriers with varying capacity over 4 lanes for 16 orders. By using the principles of combinatorics, we can then determine that this results in 720,720 possible combinations of our fleet distribution. So this result displays that even given a small number of inputs, it can quickly become difficult to choose the distribution that will result in the lowest cost by using a manual or iterative selection process. This is the reason we end up implementing our fleet logistics model. Our optimization model determines the logistics that will result in the lowest cost so that a planner can choose the most cost-effective fleet distribution every time. But the first thing we need to do is prepare our objective function. The first step in this setup is factoring in our decision variables and constraints. So we start with our order demand, which in this scenario was 16. Then we account for our available carriers. Here we have 3. And next we input our shipping lanes. So that's 4 unique lanes that we had. Finally, since each carrier has a finite number of vehicles that can be used, we consider the carrier capacities. So 8, 5, and 3 in this case. And these represent the upper bounds for how many times each carrier can be assigned an order. So once these inputs are established, our models make determinations based on the cost applied when the carrier is assigned to each lane, and will show us the optimal fleet distribution that we should select. So the objective result of this model is that we want to minimize the total cost. So this process is meant to be dynamic, meaning that it isn't something that needs to be set up every day or each morning due to the changing demand or capacity, but is automated based on your planning or demand system. So I'd now like to go a little bit deeper into how our optimization process is set up so that I can provide everyone with a better understanding of how we arrived to our results. So our optimization model is set up to solve for linear programming using matrices that we input. This means that we're solving a linear objective function that we set up with linear constraints. Our model then finds the values of the decision variables that result in the minimized objective or the cost, while satisfying all the constraints and the bounds that we have set for the particular scenario. So in this diagram, we show how the 3 main components of our model are the objective function, the set of constraints, and the objective function specifications, and how they're constructed based on the inputs that we set up when we're given a particular scenario. So here we see that the objective function is comprised of the decision variables, which are the carriers and the lanes in this case, the variable coefficients, which are the shipping rates, the RHS or the right-hand side, which are the carrier capacities, and the direction, which are, in our scenario, we want it to be equal to our capacities to optimize the fleet utilization. Next, we input a matrix representing the constraints. These include constraints due to carriers, lanes, and orders. And finally, we input our specifications. So in this scenario, for the decision variable type, we chose a binary type because we're not considering partial truckloads. We're only considering full truckloads. So therefore, we want it to be binary. And then we set our bounds respectively to what that type is. And so these components are used by the model in a decision tree format. And once all possibilities are considered by the model, it will output the fleet distribution that meets our objective function of minimizing the total cost. So Logan, I'd like to now hand it back to you to answer the question of the day. How much can we save?
Yeah, thank you, Phil. So the answer to how much savings your company can achieve through switching to this style of planning process really kind of depends. In most people's current state, they have a roughly consistent amount of money that they're going to spend each day, kind of your average spend line, like we're showing on the screen here. And as you can see, the spend line increases as the complexity and the volume increase. And this is really natural. This is a good increase because it comes from increased demand. And so as your demand goes up, you're forced to move more goods, and therefore your spend's going to naturally increase. And so that's kind of a good increase. But your current process is going to keep you pretty consistent with your average spend line. And so if we have the y-axis here represent savings, then what you're going to see is that some days you're going to save a little bit more money. Some days you're going to save a little less money as you're kind of operating through in that iterative process. And really, as time goes on, you're always going to kind of gravitate to the mean as you win some and you lose some just by the nature of the process, your current process that you're going through right now. But from the moment that you bring on your first facility onto this process, what's going to happen is that line's going to change pretty drastically. We're instantly going to see our performance level out as we don't really have that human process driving our decision making, and we're letting a model solve for what is the best possible solution. And so every day, what's going to happen is this is going to result in savings from our current process. And as time goes on, those savings are going to continue to stack up, and we're going to see how the two of them kind of deviate and the two processes grow farther and farther apart. And we're going to see this same kind of effect as we bring on more facilities and we kind of scale our solution. And so in our example, we just had 3 carriers, 1 shipping center, 4 customers, but in reality, everyone's network is going to be far more complex. And so what that's going to do is that's going to allow us to really scale this solution in a way that's going to allow us to maximize savings. And so as we go from 1 facility to 2 facility to 3 facilities, we're going to continue to see our savings grow, and our optimized process is going to put a lot of distance in savings between our current process. And so by the time we've brought our entire network on, you're going to see how each network or every single facility that we're shipping volume out of is going to be operating at greater solution as far as looking at that full holistic picture, that we're really going to maximize savings at every facility. And so across the entire network, really allow us to capture a lot more. As you bring on more facilities and you scale the solution, the savings is going to be kind of tethered to your volume, complexity, and as time, it's going to continue to go up. As we wrap up today, what I want to do is I want to touch on how shifting to this style of planning process where we allow analytics to help enable our team to make the best decisions for our company is really just the beginning of our savings journey. All throughout your process, there are going to be places where this more holistic mindset and allowing data to drive decisions is going to unlock savings. Another great example is your RFP process. RFP is request for price, sometimes called RFQ or request for quote. Once your facilities are brought onto this process, what you're going to start to see is where you have gaps in capacity. Trying to nimbly adjust your capacity to your changing demand is a really difficult task. But what this process will allow you to do is easily see where you are consistently leaving money on the table. So for example, if we don't have enough capacity on that Dallas to Chicago lane, we'll quickly see that in our reporting as the model consistently assigns more expensive carriers to that lane, or it forces us to constantly go to the spot market to get that demand filled. This is going to be a quick clue that we need to up our capacity in that region, or we're going to risk spending unnecessary dollars. At the same time, it will allow your team to better negotiate during this RFP process, as they're aware of which lanes they can offer concessions on and which lanes are going to be important to really make sure we're capturing those discounts in price. So this is just another example of how, as we switch to this process, it's going to allow us to capture savings in other areas of your logistics process, not just on the order pairing with carriers. Really, the answer to how much money you can save is ultimately up to your company and the complexity and volume within your network and how soon you decide to optimize your logistics process. If you've enjoyed hearing about kind of the strategy side and the business implications of changing your logistics planning process today, but you want to learn a little bit more about that technical side and how to actually build your own model, Phil and I will be showing a comprehensive deep dive during the Alteryx Inspire conference, where attendees will watch us build out an optimization model that solves this very problem using Alteryx. Those of you on the call who are unaware of what Alteryx is, this is just one of the many tools we use at Seacliff for our analytics. We use it for data science and a lot of process automation, depending on the client's needs and kind of their IT infrastructure. So if you do want to learn more about the technical side, feel free to sign up for our webinar there, where we'll do that more comprehensive deep dive. So while I give Phil a chance to kind of get those questions pulled up that you've submitted during the presentation, I'm going to just take a moment and let everyone know that if they have any further questions around our optimization expertise can help save your company money, or if you'd like Seacliff to come in and run analysis to see how much money you are leaving on the table with your current logistics planning process, please don't hesitate to reach out to Felicia, our Vice President of Accounts. I've added her contact information on the bottom left-hand corner of the slide here.
All right, thanks, Logan. I'm pulling the questions up right now. Looks like we have one here. The question is, does it matter what type of transportation management software I currently use?
Yeah, so that's a good question. And the answer is, it does not matter. So we've got processes in place to where what we can do is you can either have this optimization working directly with your transportation management system that you're currently set up on. And so it can be actually feeding the results in there and assigning the carriers directly to really take out that manual hands-on keyboard approach that your logistics planners are currently using. or we've got the ability to extract the data, run it through the optimization, and then what that'll do is that'll guide your logistics planners from outside of the transportation management system. If your current system doesn't allow that, it'll just kind of guide your planners and help them know, okay, this is the best carrier to pair with this particular order for this particular lane, and it'll go through and let them run the optimization kind of as needed or as orders build up.
All right, so I had another one pop up here. So the next one would be, how would you include backhaul in the model?
As I kind of touched on earlier, the situation we looked through today was focused on full truckloads, one destination for each one. But some carriers, what they'll do is they'll offer discounts if you have a backhaul that they can use so that they don't have to have any deadhead miles or empty miles. We can actually apply that same discount into the pricing strategy that we're feeding into the model. The capacity, and we'll discount some of the rates and some of the lanes to just further incentivize the model to choose this particular carrier in settings where there's a lane that they can capture that backhaul. Because I know there's a lot of discounts and a lot of extra savings to be captured if you can partner with a carrier that offers that backhauling opportunity.
Okay, and looks like I have one last one here. So how easy is it to bring on more facilities?
Yeah, that's a good question. Bringing on more facilities is pretty seamless. The first facility is always the most difficult to bring on as you're kind of working through a new company's or working with a new company and their IT infrastructure. A lot of times what we'll do, we'll go in, we'll run some analysis, we'll determine which facility are we potentially leaving the most amount of money on the table, or if we were to implement this, is it going to offer the most amount of savings? Pilot the system or the process with that particular facility, and we'll make sure we get them up to speed as quickly as possible. And then from there, as far as scaling goes, it really depends on how you've got your logistics department set up. So if all of your manufacturing facilities or all of your warehouses are all on the same system or they're centralized, then it's really easy for us to scale that to all the facilities from there. And if not, it's still possible to bring everybody on. It just takes a little bit more time. But in reality, we've really just designed the process so that it can scale, because as you saw in the graph, the faster you scale this, the more savings you can capture.
Thanks for answering those, Logan. I think this will wrap up Q&A for now, but I do want to remind everyone, if you do have further questions or if for some reason your question didn't get through, please reach out to us. You have Felicia's contact information right here on the screen. We want to thank everyone again for joining today and taking your time out of your day to listen to this presentation. We hope everyone has a great day. Thank you.
Thanks, everyone.